Okay, so here's this problem, and the problem is how many ways are there from getting from this starting cell here, this stone, how many ways are there for this chap to get from here down to this stone here? And the only rules are that he's only allowed to go east, that's a place to the right, or south, directly down. He can't go north, and he can't go from one cell left or west. So you can only go east and south. The sharks are just there to show you that it is important that he steps on the stones. He can jump over from stone to stone, from here to here. It's perfectly safe to do from there to there. The shark isn't going to get you. Okay. So, how many ways could you give me an idea how many ways there might be to get from that square to that square just by guessing? Just have a rough idea. There's one way. Could go all the way along and all the way down. That's another way. To go down, along, down, down, along, along, down, along. There's another way. How many ways have I shown you? Three separate ways. There's another couple. How many ways in total do you think there are for travelling from this square to this square following these rules?
25.
Yeah.
25, any other guesses? I think that sounded like an educated guess. 25. Okay, tell me why 25?
Because it's the number of squares altogether.
Right, there are 25 squares altogether, so maybe the number of ways to get from here to here has to do with the number of squares. That's a good question to ask, isn't it? That's a bit of a conjecture almost. I wonder if that makes sense. I wonder if that's what would come out with it. Tell me, how would you tackle this problem? What might you do?
Act it out.
Yeah, you could act out. Would you start by acting it out over all of these squares and trying to take a note of every different way you got from here to here?
Try a simpler case first.
You're trying to get a different way.
Why are you saying that? Why do you think you would try a simpler case first?
Because it's quite big, so it'd be easier to find it smaller first and then expand it.
Okay, good. Yeah, I think you're right. It'd be easier certainly, instead of us keeping track, even if you had a bit of paper, or even if you acted that out, it'd be really complicated to do all of these different ways, wouldn't it?
Yeah.
And to track what ones have I done, what ones have I not done, it would get really messy even with pens or pencils. But if we try to simplify the case in the first instance, it might make it easier. So let's think then, well, if there is just one square, how many ways are there to get to that just one square? One way, yeah? And now so far with your conjecture that maybe it's to do with the number of squares available, if there only were one square available and we're saying there is only one way to get to it, that's quite interesting, isn't it? Maybe we're headed in the right direction. You said, well, there's 25 squares, so 25 ways. Imagine there were just two squares in this pattern. Just these two here. How many ways would there be for this chap to get from this square to this square?
One.
Now that immediately says the first guess must be wrong. It's not to do with the number of squares, is it? No, it's not to do with the number of squares. It still might be 25, we don't know, but our theory of why it would be 25 might be wrong then. Okay. How many ways are there to get to this square? One. What's the problem solving technique we're using here again, guys? Trial and error?
Simpler case.
We're trying a simpler case, aren't we? Yes.
Thinking about this, so do you say 1 plus 2 plus 3? It's fine.
Well, let's have a look and see then. That's a good to keep your eye on it and say, is there something going on? How many ways are there to get to this square? One. How many ways to get to that square?
One.
How many ways would there be to get to that square?
Using all two.
One.
So if you had all of these squares here, these two rows, if you like, how many ways would there be to get to that square?
One, because you can't go to the left.
Can't go to the left, so there's just one way to go there, yeah? How many ways to this square here?
One.
It's just one.
One.
One, right? We have tried a simpler case, and what we're seeing is actually it's become quite easy to say how many different ways there are. Imagine now we just look at these 4 squares here, How many ways are there to get from this square to this square?
Two.
Okay, so we have two different answers there. Some are saying 2,
Like
some are saying 3. Did you say?
4.
4, right, okay. So we've got 3 different answers there. Some people are saying 2, some people are saying 3, and some people are saying 4. If you can show me 3 distinct ways to get from that square to that square, you'll immediately prove those that are saying 2 wrong. Yeah? If someone can show me 4 different ways, you'll immediately prove those that are saying 2 and 3 wrong. Tell me then, please, one way I could get from this square to this square. Yes, sir?
You can go to the east and then to the south.
Okay, east and then south. Brilliant, okay. That's one way. Tell me another way, please.
south and then east.
South and then east. So there's one way, 2 ways. Are there any other ways to get to that square?
No.
No. So there's only 2 ways. And if anyone had been able to show us another way, then we would be able to say, well, actually there are 3. Okay, but we can't. There's no one's coming up with a different way there. So there's just 2. How many ways are there to get to this square here? First, let me show you those 2 ways. There's one way there and one way there. How many ways are there to get to that square?
Is it 3? I think it's 3.
Can you see 3 distinct ways?
Yeah.
Yep.
Okay. Is it getting harder already? We're trying a simpler case. It's much simpler. Just a 3 by 2 is much simpler than the 5 by 5, isn't it? But already it's getting quite tricky just to say how many ways there are to get to that square. If someone's saying 3, any other answers? We're all going for 3 ways. Okay? It is 3. And here are those ways there. You can go east, east, south. Tell me another way, please. Yes?
Southeast, east.
South, east, east. And another way?
East,
East,
south,
south,
east.
east.
East, south, east. Brilliant. So there's south, east, east. And there's east, south, east. Are there any other ways to get to that square?
No.
Okay. What I want to do now is for us to employ a different problem-solving strategy, guys. So you have already started off by saying, let's try a simpler case. I want you to tell me something else that you think might be helpful for us to get an answer here as we start working our way down to a bigger square.
Well, you can see there's a pattern. It seems to go 1, 2, 3. Maybe the next one could be 4, 5.
It could well be at the start, so we definitely should be looking for patterns.
You could also act it out.
We could also act out, couldn't we?
Yeah.
Acting it out will probably give us a sense of being a bit more comfortable with the numbers as we start to fill them. And as we do that, let's do what you say as well, Laurie. Let's start looking for a pattern developing, okay? So here we are, we're acting out this situation to try and understand what's going on and to try and look for a pattern. Tell me, how many different ways could Lauren have got to that square there? How many distinct ways from the start, following the rules, only going south and along, how many distinct ways are there for her to get to that square?
3.
3 distinct ways. One was to go straight along and down, one was to go along, down and along, and one to go down and right along, and we saw those in the graphic on the screen, yeah? Okay. Tell me this, if you just walked straight into the room, and you saw Lauren standing in this square here, and you knew the rules of the game, if you said to Lauren, Lauren, what was the last stepping stone you were on? How many different answers could you give?
2.
Yeah, good. There are only 2 ways, aren't there? What squares does she either come from?
The one to her west or the one to her north.
Right, the one to her west or the one to her north. So the one above her or the one to, when we look at it, the left-hand side, this one here. Because she's followed the rules, she's only allowed to go down or to the right. So having followed those rules, we know she's either come from that one or that one. Tell me guys, how many distinct ways were there to get to that square there?
2.
2. So how many distinct ways are there for Lauren to get to that square from this square via this one?
2.
2.
2. She's either gone down, along and over, or along, down and over. There's 2 distinct ways for her to get to that one. From the other square, which is this one here that she could have come from, how many distinct ways are there for Lauren to get to that square from the start via that square? How many different ways?
1.
There's only one way. Because there was only one way to get to that square, so it'd be a straight along and down 3. Thanks very much, Lauren. Can you step aside from there for a second? Can anyone see how then we might be able to work out the number of distinct ways to get to one of these squares here?
We could add together the numbers from the square to her left and the square above her.
Brilliant. Do you agree with that? Tell me why, please. Why is that right?
because she was only able to come from her western and north, so they can't come from diagonal or lower.
Right. So there are 3 ways to get to here, because there was one distinct way to get from the start to there via there, 2 distinct ways to get from the start to there via there. And so by adding 2 and 1 together, we see the total number of distinct ways to get to that square. That's excellent. Good. And so what you've done is you have simplified the case, and now you've started to, well, you acted it out, but what have you seen?
Pattern.
You've seen a pattern, haven't you? You've seen a way to figure out what this square is going to be to get numbers in each square. So let's go back to the screen and have a look at it, please. Okay, tell me how many ways are there to get to that square there? 3. How do we know there were 3 different ways, please?
You added the one above and the one together.
Right, we recognise now there's a pattern, isn't there? Which is going to be the same the whole way down. There's the 3 different ways, and you see that 2 of them come from this square, 1 of them comes from this square, so 3 ways in total to that stepping stone. How many ways are there for me to be able to get to that stepping stone? If this was just a 3 by 3 problem, how many distinct ways would there be for me to travel from here to here?
6.
Why 6?
Because the 3 to the left and the 3 above both add up to 6.
Brilliant. There are 3 ways for me to get to that square via this one, 3 ways for me to get to this square via this one. So I can see here that there are a total of 6 routes. And what I've done is I've been able to get that 6 without the need to put all these pencil lines on it to do all these drawings. And if I'm already at 6, you can imagine how quickly my numbers are going to build up and how many pencil lines there would be to keep a track of. So we've made the problem much simpler actually by taking away the need to draw the lines, because we first of all looked for a simpler case, and then we started to act out, and then what do we see? A pattern. 3 different problem solving techniques to solve this one problem. How many distinct ways are there then to get from here to here? Tell me please, how many ways to get to that square?
4.
Okay. How many ways to get to that square?
5.
5, thank you. How many ways to get, because you 4 add 1 is 5, how many ways to get to this square here?
10.
10. How many ways to get to this square here?
15.
Okay. Are you starting to see a wider pattern emerging here at all?
Yeah, they're going up as they go along.
They are going up, aren't they? 1, 2, 3, 4, 5, and there's another pattern here. How many ways, distinct ways, are there going to be to get to this one here?
4.
4. How many ways here?
10.
10.
How many ways here?
20.
How many ways here?
35.
Why 35?
20.
20 and 15.
20 out of 15 is 35. How many distinct ways to here?
15.
Here?
35.
How many distinct ways then are there for this chap to get from here to here by following these rules? How many distinct ways?
70.
70, because you get 35 and 35. Very well done, guys. Excellent. Remember again the 3 problem solving techniques used. Number 1,
Simpler case.
number 2,
Acting it out.
number 3.
Pattern.
Pattern.
Good.